In this video, we're going to go ahead and cover sections 5.4, Sum and Difference Formulas, still part of Unit 5, Analytic Trigonometry. Before you start copying this little formula bubble here, I am going to let you know that you do have the option of doing it here or not, because very soon you will have this in your foldable as well. So in our handy dandy foldable, we're now going to have tab number 7, which is sum and difference formulas, and then a few more that we'll talk about in a different chapter. But the top ones here, so I'm going to kind of, this is what we're going to talk about later. The top ones here is what we're talking about today. So if you'd like, you can just copy these ones in your foldable, and you don't have to copy it again here. I kind of did it by accident both because I just forgot. So, twice as much is fine. It's not a big deal. But you only have to have it in your foldable at least. Okay. So for the sake of time, I am going to reference it here for now because I already wrote it down. Okay. So let's go ahead and get right into it. These are broken down into kind of like pieces. So if you're taking the sign of some kind of sum of two values, okay, you can find the value of that by breaking it down into two pieces. So let's say, for instance, sine of pi over 12. We can break that down into pi thirds and pi fourths, and that would give us, I believe, actually, I think that's for the second one here. If we subtract them, we get pi over 12. You could break it down into this formula instead, where you take sine of the first one, cosine of the second one. Similarly here, cosine of the first one, sine of the second one, multiply, subtract, and we get an answer. Okay, so these formulas are they work depending on what we're looking for. Sometimes you can break down angles into smaller angles that we're more comfortable with, like 30 degrees, 45, 60, 90, the ones that are, part of the unit circle, okay, and so forth. So here are the formulas. We have 2 for sine, 2 for cosine. I kind of put them in the wrong spot, but that's okay. 2 for cosine and 2 for tangent. We're going to jump right into an example. So let's look at example number 1 and see kind of how this works. Find the exact value of cosine of pi over 12. Well, what do you know? The one I just mentioned. So I did include a hint for you right here. And this is not going to be given to you most of the time. So you do have to think a little bit. You have to kind of be pretty familiar with fractions. Okay, so I know just from past knowledge that 12 is a combination of 3 times 4. And I know that if I subtract them somehow, if I do like 4 pi minus 3 pi, I would get that pi that I want. So I kind of said, well, let me try to break this down into a pi over 3 and a pi over 4. Why am I choosing these? Because I know that both of these are part of the unit circle, right? Remember the hand trick I showed you? Yeah? So, well, I won't go too much to the hand trick, but the first, actually, I guess I can. Remember, pi thirds is going to be your 60 degrees, which is this one, right? Pi over 4 is the middle one. Okay, so anyway, if you don't know what I'm talking about, that's fine. Look at your unit circle. You have the foldable. You have all the values, okay? So what we're going to do is I just kind of showed you how I can get pi over 12 from these two. So if you do pi thirds minus pi over 4, if you find common denominators, well, that would entail multiplying this one times 4, this one times 3, which gives us 4 pi minus 3 pi over 12, because you have to multiply the bottom. And 4 pi minus 3 pi is 1 pi over 12. So you can see that these two, if I subtract them, they do give me pi over 12. Okay, so I'm going to use this to rewrite this like so. Cosine of pi over 3 minus pi over 4. And now that I have it written down like that, I can go ahead and assign values. I can say that this is kind of like my u, and this is kind of like my v. Actually, let's use this color. I think I used blue in the foldable. Okay, so this format right here, u minus v, matches this formula right here. Okay, so what I'm going to do is I'm going to rewrite this in terms of this. So let's go ahead and do that. It's going to look like the following. Cosine of pi thirds minus pi over 4 equals, and luckily for me, I do have it right here for reference. So I can just kind of look at it Okay, let me let that focus a bit. There we go. Okay, so we have cosine of u. So cosine of u is the first one, so pi thirds times cosine of v, which is the second one, pi fourths, okay, plus sine of u, so sine of pi thirds times sine of the second one, so pi fourths. And whether you use the hand trick or your unit circle or whatever you use to get your values, you're basically going to figure out what each of these are, write them down, and then just simplify. And that is the value of pi over 12. Okay, so cosine of pi thirds, I'm going to use the hand trick because that's the one I'm most comfortable with. I know that pi thirds is going to be my 60 degrees. So if I put this finger down for 60, I'm looking at x. So I have one finger, so it's 1 over 2, 1/2. Again, if you don't know what I'm talking about, check out the daily session for Friday, January 29th in class. I do show that trick in that video, and it's pretty cool. Cosine of pi fourths is right in the middle, so this one is going to be square root of 2 over 2. Another thing you can do is look at this foldable. Remember, this one has all the ordered pairs on there, so you can also refer to this one, okay? Plus, sine of pi thirds is going to be square root of 3 over 2, okay? Sine of pi fourths, remember pi fourths is the one kind of in the middle, so that one is the same for both x and y. Okay, so we have something like this. I'm going to multiply what I can. So I have 1 times square root of 2 is square root of 2 over 2 times 2 is 4, plus square root of 3 times square root of 2. When you're multiplying two roots like this, basically you just multiply the inside. So 3 times 2 is 6. So square root of 6 over 2 times 2 is 4. They have the same denominator, so my answer is square root of 2 plus square root of 6 over 4. And this is an exact value because if I did decimals, which I do not recommend, if you do a decimal, I know you just plugged it in and that's not what I'm looking for. If I just did decimals, it would be off by decimals because it's an approximation. We want the exact value. So this would be the exact value of pi over 12. So this is equal to cosine of pi 12s. And that is it for that first example. Okay, so we're going to go ahead and do another one, this time with degrees, just to kind of show you that it works for both radians and degrees. And this one I actually already solved it for us just for the sake of time. So let me kind of cover some things here and we'll go from there. So we can see, this is my foldable to kind of cover things here. Well, we'll do it that way. We can see that we're looking for sine of 75 degrees. Okay, so you should notice right away that 75 is a combination of 30 degrees and 45. So why am I choosing those two? Because 30 and 45 are part of my unit circle. So if you can get a 30, 45, 90, what else? What other angles are important? 180 to 360, 60. You want to try those because we know how to find the values of those. Okay, so I broke it down to 30 and 45, and you can see that this one is actually color coded. Sine of u plus v is going to be the following formula: sine of u, sine of v, plus cosine of u, cosine of v. So you just kind of take sine and you do both angles, and then cosine and then both angles, plug them in, and then evaluate. So after we evaluate, or you look at either your foldable or whatever trick you're using to get those values, sine of 30 is 1/2, sine of 45 is square root of 2 over 2, cosine of 30 is square root of 3 over 2, cosine of 45 is square root of 2 over 2. We multiply everything out and we get the same thing because 1 times square root of 2 is square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4, which means we have the same answer as the previous one. So this is equal to sine of 75 degrees. Pretty okay, I think. Not too bad. Let's look at one that's a little bit different. So this one is going to give us a little bit of a headache, but It's nothing too crazy, okay? We have example 3. Find the exact value of sine of u plus v if sine of u is equal to 4 over 5, where 0 is less than u is less than pi halves, and cosine of v is equal to negative 12 over 13, where pi halves is less than v is less than pi. Okay, so what are they talking about? What is this right here? These two things are basically telling us which quadrant we're going to be looking for. When you're given something in this format, what you want to do is try to draw a picture and see if that will help you figure out what we need to do, okay? We are going to use the formula for sine of u plus v in just a bit. But before I do that, I'm going to go ahead and draw pictures here because I know that if they're telling me that sine of u is 4 over 5 somewhere in here, I should probably try to figure out where that's at. Okay, so I'm going to do that. I'm going to draw like a mini unit circle right here. And they're saying that our angle is u, and u is between 0 and pi halves. So 0 is right here, and pi halves is right here. So it looks like sine of u equals 4 over 5 is in quadrant 1. This is going to be quadrant 1. So I'm going to draw my triangle like so. And instead of theta, I'm going to use, what are they using? U, because that is what they want us to use for this one. Let me actually color code this just a little bit. So sine of u is in quadrant 1. Okay, and we know that sine is equal to opposite over hypotenuse. So that means, remember this is my right angle, opposite of this guy. So my y value here is 4. Okay, and my hypotenuse is 5. What I need to find probably, because remember that the formula uses sine and cosine, I need to find x. So x is equal to what? How would you find that? Well, you just use Pythagorean theorem, yeah? We're going to use a squared plus b squared equals c squared. In this case, we're looking at x squared plus 4 squared equals 5 squared. And by now, you should kind of be able to figure out what this is, but I can go through the steps pretty quickly. We will try to get x squared. So we're going to do x equals, you move this over. So we're looking at 5 squared minus 4 squared, and then the square root, because you got to get rid of that square, which gives us the square root of 5 squared is 25, 4 squared is 16, which is equal to the square root of 9, which is equal to 3. Okay, so that means that x is equal to 3 in this one, which means that our adjacent side, remember adjacent is x, is equal to 3. And we're going to need that because remember that for the formula, for this formula up here, we have cosine in there. So cosine needs the x. Okay, cosine always has x. Okay, so that takes care of the first condition. Now we have to look at the next one. This one says cosine of v equals negative 12 over 13. So v is another angle. Okay, and I'm actually going to, you could draw it in the same one if you want, but I'm going to draw another circle with a triangle just so it doesn't look too messy. So here's another unit circle. This one was for u. And this one that I'm drawing right now is going to be for v. Okay, so where is v? Well, it tells us where pi halves is less than v is less than pi. So v is between pi halves and pi, which would be, I believe, quadrant 2. But let's just double check. This is 0, this is pi over 2, this is pi. Yeah, so it looks like it's going to be between here somewhere. Okay, so there is my triangle. Okay, and I'm gonna rewrite the thing right here. Cosine of v equals negative 12 over 13. Remember that when we're trying to find the missing piece, so to speak, when you do Pythagorean theorem, you assume they're positive, okay, just because of the distances. The negatives at the end, you can put them in depending which quadrant we're in. Remember in quadrant 2, x is negative and y is positive, okay? Just keep that in mind. So cosine is equal to adjacent over hypotenuse. So just like the one before, let's go ahead and put let's put the v in there, right? We didn't put the v. So here is our v. And we have that the adjacent side is 12. Well, it's negative 12 because x is negative over here. But for the sake of our Pythagorean theorem, we're going to leave it positive for now. And the hypotenuse is 13. Okay, so we need this value, which is our y. So we don't know what y is at this point. Hopefully you can see it. Now it's kind of small. But we're looking for, let me zoom in and not get this to focus a bit. Okay, so adjacent of b is 12, hypotenuse is 13, and we're looking for the opposite side because remember, the formula is going to ask us for sine of v at some point. So we do need to know what the y value is for this part of the circle, okay? So we're going to do the same thing. We're going to use Pythagorean theorem to solve for that value, okay? So I'm going to go ahead and do that over here. I'm going to do, in this case, we're doing y square, right? So we're going to have y square plus 12 square equals 13 square. Okay, and it's basically the same as the one before, kind of like this one up here. We're going to have y equals the square root of 13 square minus 12 square. Okay, which I believe is going to come out to 5, but let's just double check. So 169 minus 144. If you subtract these, we get the square root of 25, which is 5. So that means that the opposite side in this triangle, which is our y, is equal to 5. Okay, so that is great because now we can plug in everything into our formula. So let's write out the formula. We have sine of u plus v. That's what we're trying to find. Let's jump over here so you can see the whole thing. Equals, well, I'm going to plug in what each thing is. So sine of, let me see. Oh, actually, let me get the formula, right? So sine of u plus v is going to be this one right here, sine of u cosine v plus cosine u sine of v. So let's do that. Sine of u cosine v plus cosine of u sine of v. Okay, you can color code everything if you'd like. I think I am, just to make it a little bit easier. Okay. All right. So sine of u we already have. Sine of u is basically this right here, 4 over 5. So 4 over 5. We're done with that part. Times cosine of v, we also have that one. That one's right here. So negative 12 over 13. So the first two were good. We have both. Those were given to us. Plus cosine of u. Okay, so cosine of u, we have to come up to this one and calculate it because we don't quite have it yet. So let's calculate it. Cosine of u is going to be equal to adjacent over hypotenuse. Okay, and since we know that the adjacent is 3, it's going to be 3 over our hypotenuse of 5. So 3/5 is going to be the cosine of u, okay? Times, oh, and I should mention, since it's in quadrant 1, everything is positive, okay? So we don't have to change anything. Sine of v. So sine of v, we have to look at the v circle now, and we know that, oh, we don't have space. Let's go ahead and put it down here. So we know that that sine of v is equal to opposite over hypotenuse, okay? And our opposite for this one we had said was 5, right? So it's going to be 5 over the hypotenuse, which is 13. Okay, so that means this one is 5 over 13. But remember that in quadrant 2, we do have one of them that's negative, so we got to just double check to make sure that we're putting our negatives wherever they go for this one. So sine is the y value, which means that we have y is positive. So we're good. We're good to go. We can leave it like this. So now that we have our values, we just multiply everything out. 4 times negative 12, let me get this a little bit straighter, is negative 48 over 5 times 13 is 65 plus 3 times 5 is 15 over 65. Same denominator, so we can go ahead and combine the top, which gives us negative 33 over 65. And this is our answer. Pretty neat, huh? Lots of work. This one is a little bit more work than the other ones, but it's not too bad. Okay, so that is it for that one. And there's most of that problem. Well, ish. Okay, if you need me to, here, I'll go at the top. So there's the top of it, and here is the bottom parts. All right, we do have one more example, so hang in there with me. One more example. We have verify the cofunction identity. So this is one of those cofunctions that we will see from time to time. Sine of x minus pi halves is equal to negative cosine of x. So this one kind of combines the previous unit, excuse me, 5.2 that we did recently with this one. So what we're going to do is we're going to work with, like we did in that previous chapter, that was so fun to work with. We're going to work with this side, the left side. Okay, so I can kind of see that there is a u minus v format going on here. So I'm going to use my u minus v format, which as a reminder, let's just write it up here. Oh, I probably shouldn't have done that. U minus v, not u. Okay, why am I putting double parentheses? I don't know what I'm doing, but don't mind the double parentheses. Pretend there's just one. That's just me being weird. So sine of u minus v equals, okay, and if we look at our foldable, because that's closer, okay, here it is. It's equal to sine of u times cosine of v minus cosine of u times sine of v. Okay, so let's use that to our advantage here. So we're going to go ahead and rewrite this in terms of this, which is going to be sine of the first one, so sine of x, times cosine of the second one, so cosine of pi halves, minus cosine of the first one, so cosine of x, times sine of the second one, sine of pi halves. Remember, when we're dealing with identities for verifying stuff, we just work with one side. So let's see what we can figure out here. I can look at cosine of pi halves and sine of pi halves because I know what the values are there. Remember that pi halves is basically at the top of the unit circle, and x is equal to 0 there. So what we have here is sine of x times 0, okay, minus cosine of x, sine of pi halves. So again, we're looking at the top of the circle. Y, which is sine, is equal to 1 times there, so times 1. And that means that this is gone, and cosine of x times 1 is just the same thing. And I believe that we are done. Okay, and that's it. That's it for that one. Something pretty simple. Looks complicated, but it's not that bad. Okay, we are going to do one more example, possibly in class if we have time. This is a big maybe, but if you want to go ahead and copy this one, hopefully we have some time to go over this one sometime next week. Okay, this is a calculus related problem, so it's pretty exciting for anybody who's like, a super math geek. That's all I have, guys. If you have any questions, as always, let me know.